So, we did a little bit of these yesterday, but we're going to go into more of them as we go. But the Common Core is really the meaning of rational exponents and roots, okay? So it's a number theory with roots, okay, rational theories. So it's the meaning of rational exponents and roots, okay? We're doing roots today. So example 1, well, that's easy. We've talked about that before. 2 and 10 is a bad combination. 2 and 10 is a bad combination. But the square root of 4 and the square root of 5 is a great combination, right? You guys agree with that? The reason I like to do that because the square root of 4 is just plain old 2. So I get 2 square roots of 5. Okay? They're the exact same value in your calculator. The reason we reduce them is later on we might be able to do something with the 2, right? They're the exact same value in your calculator, but the reason we reduce it is because it makes it easier later on to do something with it, okay? Example 2, again, something we saw yesterday. The 3, we can leave the 3 alone because it's not inside the square root. Square root of 25 and 5, right? 25 and 3, I'm sorry. Square root of 25 and 3. 3/4 makes 75. We'll leave 3 alone. 3 is a regular number. Square root of 25 is a 5. Bring down the square root of 3. 15 square root of 3. Okay, thumbs up? Easy, right? Okay. Now example 2. Before we do example 2, we've got an x squared, right? So a little side work for a minute. I know that x times x is x squared, right? So the square root of x squared has to be x, right? So I'm going to go ahead and break this down. I'll keep the 2. I'll make the 8 into a 4 and a 2. And I can take the square root of x squared as x, but I'll do that in my next step. I'm just going to do it step by step so I don't confuse anybody, okay? So I broke everything down. Mostly the 8 was 4 and 2. Okay, keep that 2 there. Square root of 4 is a 2. Now the square root of x squared is x. When you do the exponents, okay, take half. It's always going to be half your exponents, okay? That's because there's a little square root in here, okay? So the half of x squared is x to the 1, or plain old x. Square root of that. And then the square root of 2 is just left over. Almost done, right? Almost done. 2 times 2 is 4. Gage, question.
I didn't get the same sheet.
You didn't get the same sheet, huh? Okay. What you got? Sorry about that, Gage. There you go. Trade jack, huh? I don't know what that one is either. Oh, you did get the same sheet. No, you didn't. You didn't get the same sheet. All right, that's all right. We got it fixed, okay? Okay, example 5. 12 square roots of 18. Multiply regular numbers with regular numbers and square root numbers with square root numbers, okay? Now the 12 is a regular number, so we're going to leave it as 12. 12 is just plain old 12. But the 18, we can break it down. 6 and 3 doesn't help me. 6 and 3, the multiple is 18, does not help me. But 9 and 2, right? So let's make it a 9 and a 2. Square root of 9 is 3. 12 times 3 is 36. Square root of 2. Thumbs up, sideways, down. Where you guys at? I want to see. Okay, John is way thumbs up. I like that. Okay. Example 6. All right. If we just have x's, we're going to do the same thing. Let's multiply regular things by regular things. So I'm going to get a 6x. Do you see a 6x? I'm going to get a 6x times the square root of a 36x to the 4th. Don't break down 36 because it is a perfect square root, isn't it? You can leave it. So, yes, question. Yeah, to the 4th power, because I've got an x to the 1 and an x to the 3rd makes an x to the 4th. Great question. Okay, so 6x. This 6x is just sitting outside, right? Times square root of 36 is a 6, and we're going to take half the exponent, okay? Take half of it. X squared because x squared times x squared is x to the fourth. X squared times x squared is x to the fourth. That's why we take half of it. And then I'm just going to finish this up and make it a 36 x to the third. How was that one? Show me. Up. Sideways. Sideways, okay. I mean, if you're sideways, if you're all the way down, then, okay, I'll keep an eye on you. All right. Okay, example 4.
Wait, why did the exponent go from 3 to 4?
Because there was an x before.
So, yeah, I took half. Okay, so x1, Jonna,
Oh.
x3 makes x4, okay?
What about the other 2? Oh, that's not
They-
in the square
They
root.
took half of that.
I see.
Okay. Now, before I do example 4, I want to show you a little side work, okay? So we've been saying that you have to take half the exponent, right? So if I have the square root of x to the 5th, and we have to take half the exponent, I don't want an answer of 2.5. I do not want the answer of x to the 2.5. So what we do, if we're going to take half of it, we're going to actually take 1 away. We're going to make it x to the 4th times an x, okay? Got a little side work on the side here. So what I want to do is if I take 1 away from it, it makes it even, right? Which I could take half of that. I'll be left with this. This will be left over, okay? And I'll have it left over and it'll have to stay inside, right? So let's go ahead and take a look at example 4. Let's do that work, okay? So the regular, this 5x stays out. Regular 5x, right? 27, we know how to break down the 27, right? 9 and 3, right? Now this x to the 5th. Remember we talked about we want to break it up so that we take 1 away from it. Just 1 away from it. X to the 4th and x. And the reason we take 1 away, which is I took 1 away, so then we can take half of that, right? We can take half of that. All right, we're getting close. So let's take what we can. Let's take every root that we can. This 5x stays outside. We know the square root of 9 is a 3. Square root of 3 cannot do anything with square root of 3. It is just a square root of 3. Leave it alone. Take half of that. It makes an x squared, so bring it out. And then the square root of x, you cannot do anything with it. It's just, you have to leave it, okay? So let's see what's left over. What's left over is the 3 and the x. So I'll put them together inside, okay? Am I going slowly enough? It's a little bit harder. Okay, then finally I'm going to get a 15 x to the third, 3 times 5 x and x squared, okay, times the square root of 3x. Okay, that was a little bit harder, wasn't it? A little bit harder. Okay, thumbs up, sideways. Okay, all right. Okay, good. That's what I want to see. Okay, okay, ready to flip the page? All right. Okay, example 8. So, at first, when you add or subtract, they have to be the same. Okay, add, subtract, they must be the same root. They're not. Square root of 8, square root of 18. They're not. But we're going to break them down, and with a little luck, we'll make them the same, right? So for example 8, I'll start breaking it down. I'll have 2, and 8 is the square root of 4 times square root of 2. That makes an 8, which I can break down the 4 into a 2, right? I can make that a 2 times a 2 times the square root of 2, right? And then 2 times 2 makes a 4, square root of 2. So I've done the first part. I've changed 2 square roots of 8 into 4 square roots of 2. Okay. Now the second part of this, let's break down the 18. So the 18, let's use 9 and 2, right? 9 and 2. Square root of 9 is 3. Square root of 2. 4 times 3 is 12. And now they are the same. And once they're the same, we can add them. But we got to be careful. We got 4 square roots of 2 and 12 square roots of 2. The answer's got to be how many square roots of 2's, not 4's. So the answer's got to be a 16 square roots of 2, because you've got 4 of them plus 12 more makes 16 of the square roots of 2, okay? Thumbs up. That was pretty easy. You guys agree? You like that one, okay? Okay, number 9. Okay, with number 9 we have a problem. We do. We have a problem. You cannot have the square root of 3 on the bottom, right? This is the exact same one I showed you in the reading, right? So we fixed the problem with the problem, okay? What's the problem? Square root of 3, right? So we're going to multiply top and bottom by the square root of 3 over the square root of 3. It's got to be both, top and bottom, by the same thing. So what I'm doing is multiplying by 1, and 1 wouldn't change the value, right? Okay, so let's see what we get. I'm going to get 5 square roots of 3 over the square root of 9, right? Which square root of 9 is 3. So I get 5 square root of 3 over 3. Okay. Last problem. Okay. Now, example 10. Am I going too fast or okay? Okay, example 10. There are a couple of ways to do this, okay? There really are. And I want to show you the easiest. I really do. I could multiply by square root of 6 over square root of 6. That is what you'd think you should do first, right? Wouldn't you think that? But if I break down 27 and break down 6, let's see what happens. 27 square root, see, I'm going to go 3, and I'm going to go square root of 9 and the square root of 3, right? Yes. Awesome.
For 6, could you do 4, square root of 4 and the square root of 1.5?
Where you at?
Or when you simplify 6?
6? Number 6 or what? Oh, the 6. Oh. Yes, but I'm not going to do that, okay? Really good idea, though, by the way. A really good idea, but I'm not going to do it that way, okay? Because I think you're going to see what I'm going to do. Hopefully you're going to see. How if I write the 6 as square root of 2 times square root of 3? Now, that normally isn't a good idea, right? But you can see this time it's not a bad idea. Normally, 2 and 3 I would never use for 6, but this time 2 and 3 is going to help me because I can cancel that right there. See how I did that? So now let's see what I have. I've got a 3 times a 3 over 2 square root of 2, okay? I got the 3 from right there, okay? I'm making this too hard, or you're getting it? So then I get a 9 over 2 square root of 2, but I still have a problem, don't I? Still have a problem. So let's fix the problem with the problem. Square root of 2, square root of 2. I'm going to get 9 square root of 2 over 2 times the square root of 4. Which is going to be 9 square root of 2 over 2 times 2. Which is going to be almost done. 9 square root of 2 over 4. That was a little harder. Okay, now 1, 2, 3, 4, 5, 6 problems. That's it, right?